All right, good evening. It's 8 o'clock, so we'll go and get started. Have a lot to cover today. All right, so this is towards the end of the third week of this introductory Java class. So let's just get right into it. So last week we talked about, different variables and how to assign variables, how to do, some simple math, just some adding, some numbers together, getting input from the user, and doing something with that input, different ways we can print out things. So that was all, in week 2 type stuff. Now in week 3 we're getting into obviously slightly more complicated material. So this week we're going to talk about, relational operators, precedents, code blocks, if else statements, and switches. So we'll kind of run through all that, and at the end we'll give a few, notes about your assignment that's due this week, and then we'll open up for a question and answer session. If at any time during this presentation, if you have questions at any time, just go ahead and unmute yourself and ask your question, or you could put something in the chat box, and as soon as I realize there's something there, I'll go ahead and take your question as we go through it. All right, let's talk about relational operators. Relational operators you've probably seen throughout your school time, even back in elementary or middle or high school. And what we mean by relational, we are comparing two values together. Are these two values equal to each other? Are they not equal to each other? Is one less than the other? Is one greater than another? And so on and so forth. And whenever you ask yourself that, set aside programming for a second and just logically thinking, if you say, is 2 less than 1, just for example, right? That is really a yes or no question, right? It's either true or it's false. So if I were to say 2 less than 1, what does that mean that is? That's false, right? Because 2 is not less than 1. So if I'm trying to say 2 less than 1, that's obviously false. So let's just think about that being false. If I say 1 less than 2, that would be true because that is a true statement, right? 1 is less than 2. Let's expand that a little bit. If we say 1 equals 1, that is true, right? Let's take away the equals mark so it doesn't look confusing, right? If I say 1 is equal to 1, that's true. And when you're doing Java, if you want to compare if something is equal to each other, you have to use 2 equal marks. The reason for that is if you just put 1 equal mark, it's like you're trying to set a variable equal to some value. So, if we have an integer called a and we want it to be the value 2, we would do that, right? That makes it an integer variable. The name of it is a, and it's equal to the value of 2. This is stuff we talked about last week. So when you have a single equal mark, that's what we call an assignment, meaning you're trying to make this equal to whatever that is. But when you want to do a comparison, you have to use the 2 equals marks. That's just the way you differentiate in Java and most programming languages, that you want to compare two things is with the double equal mark. So 1 is equal to 1, that's true. If we would put 1 is equal to 2, that's not true. That would be false. Likewise, we can have 1, 2 less than or equal to 1. That's false. We can have 1 less than or equal to 2. That's true. What if we had 2 less than 2? Is that true or false? That's false because 2 is equal to 2. It's not less than 2. So that's false. But what if we had 2 less than or equal to 2? That ends up being true because we're saying it's less than or it's equal to this other value. So that would be true. So you see, this is the way that we can compare many different things. We can have less than. Actually, let's run through them all. We have double equals, which means equal to. We can have the exclamation point equals, and that means not equal to. So in that instance, if we had 1 not equal to 2, that's actually true, because this says they are not equal. And so 1 is not equal to 2. So that ends up being true. So that's what the exclamation point equal means. We can have that, which means less than. We can have that, which is greater than. We can have that, which is less than or equal to, greater than or equal to. Right? That's all the different symbols that we can have. And that's really all the ones you really concern yourself with, are just those right there. The way you can compare values together. And like I said, when you're comparing values, it really ends up being a yes or no question. It ends up being a true or false question. Is this comparison true or is this comparison false? And we can look at some of those by just printing some of them out. Let's print out some things. Let's print out 1 equals to 2. What is that going to print out? Well, as I said, this is going to resolve into either true or false. So if we print this out, it should give us false. We run it. And there we go. It prints out false, because that's correct. 1 equals to 2 is false. If we put 1 equals to 1, now we should get false printed for this one and true printed for this one. Right? We're just comparing numbers, false and true. And you can do that with any of these operators that we showed. See, greater than, 1 greater than 2. That's going to be false. Let's do a few of them. We'll do 3 more. 1 greater than 2, 1 less than 2, and 1 greater than or equal to 2. All right. So what are we going to get here when we print this out? So 1 equals to 2, that's a false. So this should print false. 1 equal to 1, this should print true. And 1 greater than 2, that should be false. 1 less than 2, that should be true. And 1 greater than or equal to 2, well, that's still false. So that's what we should get for our printout. Let's make sure it works. We'll run it. There we go. We get false, true, false, true, false. False, true, false, true, false. So it ends up being correct. Okay. Now, why we need to do this comparison, we'll see a little bit later this evening when we get to the if statements. But just know that this is how you can compare two values. And you're not limited to just integers. You can do floats, or you can do the floats, you can do the doubles, you can do integers, you can do shorts, longs, etc., etc. Any numerical value, you can use this comparison. So for example, we could have 1.3 equal to 1.3, and that should be true, right? Let's run it. Indeed, that is true. Let's do 1.3 less than 2, and that's fine. Even though this is technically a double and this is an integer, you can still use your comparisons on those. This should be true, and it is. It's true. So any numerical value you can compare like this. Now, it gets tricky when you do strings. You can't directly compare strings like this. For example, if I say me equals me, is that going to be true or false? The answer is you don't know. Right now it says true. But the thing is, that may not always be the case. Let's look at this. If I have this string value called m, and I say me, now if I say m is equal to me, I still can't be guaranteed that this is going to be true. Let's run in and see what happens. Sometimes it will be, sometimes it won't. It does return true here. do a slightly different example. Put them both to be me. Does M equal N? They're both a string. They're both the word me. It still returns true. But the thing is, you can't be guaranteed that's a fact. It just doesn't work right for strings. And there's some background information there about these being actually reference types. That's a little bit beyond the scope of, at least for this week. But just know that these are not exactly the same as your numerical values. The numerical values, you can always do these comparisons, equal, not equal, less than, greater than, et cetera, et cetera. With the strings, you don't want to do that because it may not always give you the output that you're expecting. But there is a way we can compare strings, and it's better done like this. We have this string. The name of the string is M. We can put M dot equals, and then the other one, which is N. We could do that. This is really the way that you want to compare strings to each other. All right. I actually think we're going to get to that maybe next week or so. But just know that, comparing strings with the equals and the less thans and the greater thans, it may give you what you're expecting that time you run it, but it may not always be the case that it gives you what you would expect the right answer to be. You need to use the name of the variable, a dot, and then equals, and then inside these parentheses is the other string you want to compare it to. Okay? That's actually probably stuff for next week, but just want you to understand this week when you're comparing integers and floats and doubles, you can compare those fine. Just when it comes to strings, you have to be a little bit more careful about how you compare them. All right, so those are our comparisons. Let's talk about two more topics before we get to the most important thing, which is the if statements. So talk about precedence. Precedence is really it's the same thing you call in math class your order of operations, right? Even going through, I think maybe starting in middle school, certainly in high school, when you have these math formulas and you have additions and subtractions and multiplications, divisions, et cetera, et cetera, et cetera, there's a certain order that you have to do those in. It's called the order of operations in math. In programming, we just generally refer to it as the precedence, which means some math operations get done before other math operations. And let's look at the order. So first, just like math class, we'll have the multiplication, the divide, and the remainder. The next precedence, and we'll do examples of these. The next precedence is the plus and the minus. The next precedence is the less than, is our comparisons like we just did. Less than, greater than, less than or equal to, greater than or equal to. The next precedence is the equals or not equals. The next precedence is the and the next precedence is the or. And we'll see what the and or is here when we get to the if statements. So what that means is, let's say I have this math. Let's say I have A is equal to 5 plus 4 times 10, right? What is the answer to that? Oops. Let's print it out. System out.println. We'll just print out A, what the answer is. So what should the answer to this be? Well, we have to look at the order of precedence. First, we have to do any multiplications, divisions, and this is the remainder operator. I don't remember if it's been covered yet. But what this does, it just tells you the remainder of some division you do. So, getting a little bit sidetracked. So if I did 3, and it's called mod, is what this is called. This is called mod. So if I do 3 mod 2, what that does is it takes 3 divided by 2, and whatever the remainder is the answer. So the remainder will be 1. 3 divided by 2 has a remainder of 1. See, 13 divided by 4, excuse me, 13 mod 4, that's actually let's do 14. 14 mod 4, it's going to be 2. Why? Because 14 divided by 4 is 3 with a remainder of 2. So that's that's what that means. This means the mod. It means give me the remainder of this division. All right. So back up to the precedence. So first we have to do any multiplication, division, or mod. And so we look at our formula here. Okay, well, here's a multiplication. Yeah, this plus, if we're reading it left to right, it comes first, but because we have this precedence, it's not the first math that's done. This 4 times 10 is done first because it's at the highest of the precedence. So the 4 times 10 will give me 40. So what that changes into 5 plus 40. So now we do the next layer down. We do any pluses or minus. Okay, well, that's a plus. So then we do that addition and we get 45 out of it. Let's run it. And you see, we do get the 45, right? Just like if we add a -1 onto the end here, what happens here? Well, we still do the multiplication first. So if we multiply this out, it's still 40. So this turns into 5 plus 40 minus 1. Okay, what comes next? Okay, anything with a plus and minus. Well, these have pluses and minus. And it turns out it really doesn't matter which one you do first or not. You can do either one first. So if we were to do the 5 plus 40, that turns into 45 minus 1, which turns into 44, right? Excuse me. So that's if we did the 5 plus 4 first. But if we do the 40 minus 1 first, we actually get the same thing. It'd be 5 plus 39 if we did this first. And 5 plus 39 is still 44. So we get the same answer. But the important part to remember is, when we have these different operators, we have a plus, a multiplication, and a minus. You have to do it in this order. First, do any multiplications, any divisions, any mod. Next, do any pluses and minuses. Next, do any comparisons. Next, do any, is it equal or not equal? And then the and the or we'll look at whenever we get to the if statements. All right. There is a way you can change this up a little bit. So when we run this right now, we get 49, right? Or excuse me, 44. And that's the right answer. But let's say we wanted to change this up a little bit. Actually, one it doesn't have on here is the parentheses, right? So if you want something to happen first, you put in parentheses. So even as it is right now, the multiplication comes first. But if we put parentheses, let's say here and here, it does what is inside the parentheses first. So what this turns into, okay, it'll look at it and it sees, okay, parentheses is the highest precedence, so do the parentheses first. So, okay, do this parentheses. So we have 5 plus 4, that'll be 9. The times still remains there. Here's another parentheses, 10 minus 1. So that's a 9. And now we only have one thing to do, and that's 81. All right. I see your message, Robinson, and I understand. Okay, so now when we run this, we should get 81 as the answer. And it all just depends on those parentheses, right? With the parentheses, it's 81. Without the parentheses, it is 44. And it all has to do with this precedence, the order in which mathematical operations take place. All right, so that is our comparisons. That is our precedence. Next thing we want to talk about is code blocks. Code blocks is just a way to logically organize statements of your code. What I mean by that, well, first of all, what does a code block look like? A code block looks like a beginning bracket and an ending bracket. Oh, curly brace. I guess we call these curly braces, right? So you have a start and an end. That means anything inside of here is a code block, right? And you can have multiple of them. You know, we can have another one. Anything inside of here is a different code block. Okay. You can have another one. And we will see why they are useful shortly. So this really gives us 3 different code blocks, right? And let's just call this one code block A, code block B, and code block C. This is just so that I can refer to them as I'm talking to you. So inside of code block A, anything in here, if I can spell, anything in here cannot access anything inside B or C. So you can think of a code block as kind of isolated from other code blocks. So if I have some kind of code inside of here, it cannot interact with code here. It cannot interact with code here. It kind of logically separates different sections of your code. However, we can have nested code blocks, meaning inside of A, we have another one. Let's just call this A1. Okay. So A1 cannot access B or C, but A can access A1. And what that means is inside of your code block, you cannot access anything outside of it. However, this parent code block can access anything like downstream of it. Get rid of some of these extra comments, makes it easier to look at. We'll just have the code block names. So inside of A1, I can only access stuff inside of A1. A can access this code block, and it can access its own code block. So you can think of A1 like a child of A. And it's, like I said, it's a way to kind of isolate code from other code blocks. And if you look at our actual whole class itself, you know, our public main class, it has a curly brace right there, and the end of the curly brace is down here, right? It has all this main stuff in between. So this whole class is a code block that starts right here and ends right there. Likewise, our main function is also a code block. It has a curly brace starting there, and it ends right there. So anything between these two curly braces is the main code block. And so they're really child code blocks of your main function. So your code blocks can access things inside of it, but it does not go the other way, meaning A1 cannot access A, but A can access A1. That's what we call a code block. You can have whatever you want in here. You can have this int A is equal to 5, or whatever. Int B is equal to 3. And those are, and it's not good. We'll call that A1. So it's the code block. We have int B is equal to 3. So this B cannot interact with this A. So if we were to actually put B is equal to A plus 5, it's going to complain to me because this code block does not know what A is, because A is inside of a different code block. So this code block cannot access that A. It's isolated from it. So how are these code blocks useful? And we get to probably the most important concept of this week's lessons. And it's all about if statements. Let's look at if statements. So sometimes when you're deciding whether to do something or not, you make a decision, right? You think, okay, if this or this, then I want to do something. Otherwise, I'm not going to do it. Let's say I want to go to the movies, right? Let's say I want to buy a movie ticket, but I'm broke, right? So how do you decide if you want to go see the movie? I mean, there could be many things that make your decision. You need to decide, do I have enough money to buy the ticket? Do I like the genre of the movie? Does the previews look good? Does it have my favorite actor in it? Right? And what's kind of consistent with all those questions is they're all yes or no questions. They're true or false questions. So if I have enough money to buy the ticket, if I like the genre of the movie, yes or no. If I like the previews of the movie, yes or no. If it has my favorite actor, yes or no. Those go back to those yes or no questions, just like we had here with these different comparisons. These are yes or no. It's true or it's false. So think about when you're thinking about the movie. Let's just reduce it down to one thing. If I have enough money to buy the ticket, I'm going to go watch the movie. Okay. So you need to answer true or false. Do I have enough money to buy a ticket? Right? If I do, I'm going to go see the movie. Right? We can do the same thing in our code, meaning if something is true or false, then I want to execute some piece of code. If it is not true or false, then I'm just going to completely skip it. And that's what this looks like. Let's keep it in just generic, English language, like going on with the same example of a movie ticket. So let's say if I have enough money for a ticket, right. If I have enough money for a ticket, then I want to go watch the movie. That's kind of what that looks like in Java-ish code. We have to fix this up a little bit. But what we do, we start off with the word if. Then we have these parentheses here at the start and the end. Inside of here is where you want to put your comparison. Inside of here is something that needs to be either true or it needs to be false. So you could think, if I look at the money in my pocket, if the money is more than $10, then I can buy a ticket, right? So here you would say, you would put that comparison. Is the money in my pocket greater than $10? So that's what goes in here. It's either something that turns out to be true or something that turns out to be false. Then we have that closing bracket, that closing parentheses, and then we have a code block. We have the starting curly brace. We have the starting curly brace and the end curly brace. Okay? And inside of this code block is anything I want to do if it's true. So first I'd probably buy a ticket. Then I would probably drive to the theater. Then I would watch the movie. Then I would drive back home, right? Those are all the things I want to do if I have enough money for a ticket. Again, if something that is true or false, if this is true, I want to do everything inside of this code block. If this is false, I'm going to skip all of this and just go to the next line. So if it's true, do this and then go to the next line. If this is false, skip all of this and go to the next line. And all of it is this code block right here with the starting curly brace and the ending curly brace. So let's do an example of this in actual Java code. So first, we're going to buy a movie ticket and see a movie. Okay. So first, we need to figure out, okay, how much money is in our pocket, right? So let's get that from the user. Let's ask the user how much money they have. We'll make a scanner from the keyboard. This is stuff from last week. We're going to ask the user, how much money do you have? Question mark. Oops. Yep. We're going to have them tell us how much money they have. So we'll get a float. We'll call it money. It's going to be equal to the scanner.next float. So now the user is telling us how much money they have. Before we try to write the entire thing, let's just test this out if this works so far. So I've made a scanner. I'm just printing out, hey, tell me how much money you have. Then I'm using the scanner to get the amount of money. And then right now, I'm just going to print out the amount of money. I want to test my program to see if it works so far. So let's run it. Or you see here, how much money do you have? I have $3.25. And then it just prints back out $3.25. So I know it works so far. It's getting my amount of money from me. Okay. So now we need to figure out, is that enough money to buy a movie ticket? Let's look right here. It needs to look like this if something that is true or false. So let's put if. What do we need to check? We need to say, is there money greater than or equal to the price of a ticket? How much is a movie ticket? I don't know. Let's just say it's $12. So if the money is greater than or equal to 12, because that's the price of the ticket we made up. So if it's greater than 12, we are going to the movies. And then I'm just going to put another line on here so that we know it's after. This is after the if statement code block, just so we can see that it does actually go there. So what will happen? Again, I'm making a scanner to read from the keyboard. I'm asking the user, how much money do you have? I'm getting that from the keyboard, letting them type in how much money they have. If the amount of money they have is greater than or equal to 12, let's just say because the ticket is $12. So they have enough. If this is true, then they have enough money, and yay, we're going to the movies because this is the code block. If that's true, we're going to do this code block and then go to the next line. If this is false, we will skip this code and go to the next line. So let's run it. All right, how much money do you have? I have $13.20. Yay, it says we are going to the movies, and then this is after the if code block. And that's right, because I typed in 1320, so 1320 greater than or equal to 12. That is true. So I executed the statement. Let's run it again with exactly 12. And what's going to happen? We're still going to the movies. Why? Because money was 12. 12 greater than or equal to 12. That is still true. So we execute this code block. Let's run it again. I have $1.33. Oh, we're not going to the movies. We didn't print out we're going to the movies. We just got to the code after the if statement. So what happened? Money was $1.33. So we said 1.33 greater than or equal to 12. That is false. So I skipped this code block, and notice I did not print out going to the movies. So we skip that code block and we execute this instead. Or excuse me, we skip the code block and then we go to the next line after the code block, which is right here. So that's how we can use an if statement. Let's do one more example. Let's make a determination on if someone gets a senior citizen discount. So let's ask, if you get a senior citizen discount, you're usually 65 years old or older, right? So let's ask how old they are. How old are you? And for age, that's more of an integer than a floating point number, right? Instead of next float, we'll get the next int. So now let's determine if they get the discount. So if their age is greater than or equal to 65, then you get the discount, right? You get the discount. And then we'll go to after this statement. This really isn't any different than the money for a movie ticket, but it's just showing you can use this for any kind of numerical comparison you want to make. Let's run it. How old are you? 33. Then we just get, this is the message after the code block. We did not get the discount. We did not get the discount. I didn't print it out. Let's run it again. And now if I'm 77, yay, we get the discount. And you can imagine, you're writing the code for the computers that sell tickets, and you're going to have stuff like that in your code. You can be like, hey, the ticket costs $10, but if they're a senior citizen, maybe subtract $5 off the ticket. So that's how this could be used in a real world scenario, right? That's why you need these if statements, because you only want to execute code if a certain condition is met, if this is true. So let's combine that. That is the if statement. Let's combine that with another thing called else. And it looks like this. So what happens in this scenario? Well, I'll put in the code here and then we'll discuss how it works. You do not get the discount. So what happens here? So again, just getting the scanner, asking how old they are. So we have if that age is greater than or equal to 65, if this is true, we want to execute this. And what the else does is, if this is false, we want to execute the else. So if true, execute this. If it's false, execute this instead. And no matter which one it executes, after it's done with its code block, it'll just go to the next line after the code blocks. So let's see that in action. We run it. How old are you? If I put I'm 11, then you do not get the discount. What happened? So age was 11. So 11 greater than or equal to 65. That is false. So because we have this else, this gets executed if it's false. And you can see here, it did print out, you do not get the discount. Let's run it again. This time we'll say I'm 88. It just says you get the discount. And is that right? So age was 88. So 88 greater than or equal to 65. That is true. So we execute this code block. Print, you get the discount, which it does. And then it skips and goes to the next line after the code blocks, which is right here. So again, if true, execute this. If that is false, execute the else. And the else is not required. You can leave off the else, and that's perfectly fine. It works just fine. But you won't be able to do that extra piece of code if it's false. If that's false, It just basically does nothing and goes to the next line. The else is there if we want to do some code, if that turns out to be false. And for our example, if their age is greater than or equal to 65, I'm going to say you get the discount. If that is false, I'm just going to say you don't get the discount. So that's how the the if and the else statements work. One last thing about the if statements is you can have what we call nested if statements. Let's make this a little bit simpler. Just have the if statement. So let's go back to our movie ticket example. So let's go back to our actually no, we'll keep it with this. Let's say we're going to go get a movie ticket and we need to figure out how much to charge somebody, right? So let's say if they're a senior, they get a discount. But if it's a 3D movie, we're going to charge them more. All right. So that's getting a little bit complicated, but it's going to say out like this. So a standard ticket is, say, $10. Okay. Senior citizen gets tickets for $5. If it's 3D movie, then it's an additional $2. Right? There's several different things we need to check on and see if it's true or false to determine how much they charge them. So standard ticket is $10. If they are a senior citizen, it's going to be $5. And no matter which one of these it is, if it's a 3D movie, we're going to add $2 more onto the price. So let's see how we can do this with some if-else statements. Okay, so first we need to ask how old they are. That's fine. Now we need to ask, actually we'll ask first, is it a 3D movie? Because that's something we need to know to decide how much to charge them. Is it 3D? Question mark. And we want just a Y or N. Yes or no? We're going to call that string 3D scanner.next. Yeah, next line should be fine. Okay. So let's look at what we're doing here. So we made a scanner still. We're asking, is it a 3D movie? Yes or no? Why? Because we're going to charge them extra. So we need to ask them if it's a 3D movie. And that 3D is going to be either a Y or an N for yes or no. Then we're going to ask them how old they are. Why do we ask them how old they are? Because a normal ticket is $10, but if notice how I even use the word if they are a senior citizen, it's only going to be $5. So that's why we need to know how old they are. Let's figure out how to do this. So first we're going to check if they are a senior citizen. So put the else there. So if this code block, then they are a senior citizen. Else, so if we're in this code block, they are not a senior citizen. There we go, right? So if it's in this code block, they are a senior citizen. Else, they are not a senior citizen, right? Get rid of that. So now we know normally this would be $5, right? Normally this would be $10, right? But we also need to take into consideration if it's a 3D movie. So we need to check if it's a 3D movie. So if the 3D, remember I said it's bad practice to compare strings like that. It's just bad practice. So we do if the 3D dot equals a y, then if this code block, let's see, we are a senior citizen watching 3D. Else, senior citizen not watching 3D. And we'll go over this carefully as soon as I get all the code in. And kind of the same thing down here. Except instead of senior citizen, down here we're just a citizen. We're not a senior citizen, right? So let's look at how this works. So you can imagine we put in some information. Actually, let's go ahead and run it, put in the information, and then we'll follow through the code what happened. Actually, we need to put some print out to tell them how much we're going to charge them, right? So cost is, so if they are a senior citizen watching 3D, how much should it cost? Well, senior citizen is $5, but 3D is $2 more, so it should cost them $7. All right. If it's a senior citizen that's not 3D, it's just the $5. Likewise, if it's a normal citizen watching 3D, it's the $10 plus the $2 for 3D. So that's $12. And then if it's a citizen not watching 3D, it's just the $10. Let's run it, see how it works, and then we'll trace it through the code to see where all it went. So we run it. So is it 3D? I'm going to say, no, it's not 3D. And I'm 55 years old. And so the cost is $10. Is that correct? That is correct because I'm not a senior citizen and it's not 3D. So it's $10. That's right. Let's run it again. Let's do yes, 3D, but also 55. It costs $12 because the ticket is $10 plus 3D is $12. Let's run one more example and then we'll see it in the code. We'll do, it is a 3D movie. They're 88 years old. The cost is $7. Is that correct? Well, the senior citizens get a ticket for $5. The $3 means, excuse me, the 3D, yes, means we add $2 more, so it is $7. So how do we get there? How does that work? Let's take this example where we put in yes and 88. And you can see here how we have the nested if statements inside of each other, meaning this if statement is all of this code block from the start curly brace to the end curly brace. So that's that if statement. But inside of the if statement, we have another if statement, which goes from there to there. And then the associated else from there to there. So let's see what happens when this is yes and this is 88. Okay, so we say 88 greater than or equal to 65. That is true. So we do everything inside of this code block. Okay, well, the first thing in the code block is if the 3D is a Y. That is true because I put in Y. So I execute everything inside of this code block, which says, the cost is $7. Let's run it one more time. Let's say it's not 3D and there's still a senior citizen. So when we run it like that, no 3D and they're 88 years old. So let's check here at the top. We do the input. So 88 greater than or equal to 65. That is true. So we execute this code block. So inside of here, we say if the 3D equals yes, that is false. Since it's false, we do the else code block, which prints out $5. Right. So that's kind of the most complicated thing for this week. I'm briefly going to talk about the assignment. And then if you have any questions about anything, we'll go ahead and take those then. So for the assignment, You got to use these if-else statements to do things, right? So for your assignment, you're basically going to be making like an extremely simplified calculator, right? You're going to input two numbers, and then you're going to input a math sign, either the plus or the minus or divide or the multiply, something like that. So your assignment is going to look something like this, at least the input. Yeah, forget this code right now. We're talking about the assignment right now. So the input to your program looks like this. So you do one number, a second number, and then you'll either do a plus sign if you want to add them, you do a minus sign if you want to subtract. You can do division, or you can do multiplication. You do any of those three things, right? That should be the input to your program. So what do you got to do to make that happen? Let's write a little outline of what your program should look like. Yeah, we'll just put it up here at the top of this file. It's fine. So first thing we need to do is get the first number input, right? Next, you need to get the second number input. Next, you need to get the math operator. And I mean by that, the plus, the minus, the divide, the multiply. You can do the remainder if you want, whichever math operation you want to do. So the next thing your assignment specifically says this is the two numbers must be between 200 and 1,000. So how do we check if a number is between 200 and 1,000? Well, I'll give you part of it. So let's say we have the number n is equal to 5, right? How do we check if it is between 200 and 1,000? I'll give you how we see if it's, I'll give you part of the answer here. I'm not going to give you the whole thing. So the first thing we need to do, we need to say if the n is less than 200, then it's out of range, right? You probably need to do something, right? Because if the n is less than 200, then it's not, within that range. And Cameron is right, is you need to use an if statement with the and. Yeah, one of the things I didn't talk about during the discussion this evening, it is in your course material though, is you can compare multiple things at the same time. And what he's referring to here, we can put and n is the greater than was say 1,000, right? So really this is two true or falses, right? We're doing this comparison. These two ampersands just means and. We're doing this comparison. What this means is we're looking to see if both of these are true. That's what the and is. Conversely, we can do these two. These are called a pipe symbol. It's the symbol on your keyboard right above the enter key. This means or. This means if n is less than 200 or n is greater than 1,000, then it's out of range. If it's out of range, we probably maybe print an error message and maybe end the program, right? That's probably the way that you want to check if the number is within range or not. So in this instance, at least the way I'm structuring it, Cameron, we would use an or here. If you use an and here, then what you're saying is if this is true and this is true. The thing is that will never happen because let's just think of a number. If n is 500, right? If n is 500, then it actually works out because that's false and that's false. But let's think of if n is 5,000. So if n is 5,000, it is out of range and I should reject it, right? But what will end up happening is we'll say 5,000 less than 200. That's false. And 5,000 greater than 1,000. That's true. So here I'm saying if false and true. If I want to do this code block, then both of those have to be true. But that's not going to be the case. I just gave an example of a case where a number is out of range, but it doesn't work like we want it to work. Likewise, let's say the number is 5, just like our example here. If the number is 5, we're going to say 5 less than 200. That's true. And 5 greater than 1,000. That's false. So both of these are not true. It's true. There's a true and there's a false. Both of them have to be true in order to do this code block. If it's an and. So even though the number is outside of the range, it's still not going to do this because both of these are not true. You can fix that by putting the 2 pipe symbol, which means or. And with the or, it means if either one of them is true, then we'll do it. So let's use our example again. If n is less than 5, n is equal to 5. So 5 less than 200, that part's true. Or 5 greater than 1,000, that part's false. But since it's or here, all I need is just one of them to be true, and I'll execute my code block. Let's do the quick example of it, 5,000, just to see that it still works. So 5,000 less than 200, that is false. Or 5,000 greater than 1,000, that is true. All I need is one of them to be true. One of them is true, so I will do this code block that says it's out of range, print out an error message, and end my program. So that's probably more than I wanted to give you, but you attended the Zoom, so you get a little bit extra help. So that's how we can check if a number is in range. Actually, this checks if it's out of range. If it's out of range, then it prints an error message and quits the program. Okay, so this is one thing you have to do for your assignment. For whenever you get this number input, you have to make sure it's in range. When you get this second number input, you have to make sure it's in range. All right, so that's checking the range. So I'll actually add that here. Check range. All right, math operator, and we have to check if it is valid math operator. And so we need to decide what to do, right? So let's imagine we got the number. A is input from the keyboard, right? We asked the user what it was. B is input from the keyboard. We're getting this first and second number. Right now, I'm skipping that range check, but you need to do the range check, okay? So now we need to get that math operator, call it O, input from keyboard. And that's either going to be a plus, a minus, a multiply, or a divide. You can support other ones if you want to, but those are really the ones you need to worry about. So you need to do some checks. You need to say if the O is the plus sign, right? Then we want to add, let's just say C is equal to A plus B. Print out C. That's kind of the gist of what you need to do. Well, if it's not a plus, if the O is, say, subtract, then C is equal to A minus B. And print out the answer, right? That's kind of how your program needs to look like to meet the requirements for the assignment. Like I said, one thing I'm not doing, I'm not checking the range of these numbers. You need to check the range of the numbers. The assignment specifically says to check the range of the numbers. You need to do all of these math operators. Right now, I've only done the plus and the minus, but you also need to support the other math operators. And like I said, this isn't exact code you can just copy and paste into your assignment. Because this isn't 100% valid Java code. It's what we call pseudocode. It's almost like a programming language, but it's more in plain terms to get the idea across. You kind of need to take this idea and make it actual Java code. Okay. So you need to watch out for those number ranges, and you need to print out error messages if something isn't right. Meaning, if the number is out of range, you need to print out an error message that's out of range. If the math operator is not one of those, then you need to tell them, hey, this isn't valid. For instance, if I put in the inputs, if I put in 100, 200, and a plus sign, the answer it gives me should be 300, right? This should give me 300, right? If I put in 100, 200, a minus sign, that should give me minus 100, right? If I put in 1300, 100 plus, that should give me error message number out of range. That's what my program should do. If I put in, well, actually, those are out of range too. Let's see, 200, 200, make them in range. That should be what it looks like. If I put in 400, 500, and a dollar sign, that should give me an error message, invalid operator, because a dollar sign isn't a mathematical operator. I can't, what do you do with a dollar sign? What does that mean with two numbers? It doesn't mean anything, right? So these are the things your assignment needs to do to make sure you get all the credit. And of course, with it, make sure you're doing the test reports. Make sure you're doing the test report correctly. If you don't know what the correct test report looks like, you can refer back to the week 2 material titled Test Reports, and I'll show you exactly what test report looks like. You can email me and ask me for assistance with the test report if you have a problem with the test report. But your test report is extremely important. It's important you do it correctly. All right. So that is all the material for week 3. That's a little bit more help than I probably intended to give you for the assignment, but that's what it looks like. And I'll open it up for any questions. All right, nothing heard so far. I'll hang on for about 1 more minute. Should anyone have a question? Oh, actually, I see a question in the chat. I keep having a problem where else where it prints the else statement even after the if statement. If you can send me your code that is having that problem, that certainly is not something that should be taking place. If we look at my if else statements I have down here, wherever they're at, like this if else statement, it really should be, if this is true, do this, else do this. What you may be doing is, if you have like a semicolon here, that may be causing the thing you're having a problem with. I'm not sure. I would have to see your exact code to see where you're having that issue at, because certainly that is not something that should be taking place. So please email me your code and specify on what line it is you're having that issue with. I'll hang around about another minute. If anyone has a question that pops up. Session is being recorded, so I will get it posted up probably later on this evening, so you can review it at your convenience. All right, we'll go ahead and end it. Like I said, if you have any questions, email me early, email me often, and I will get back to you as quickly as I possibly can to help you out. Whenever you do email me a question, please always attach your code file to it and explain to me where in the program you're having the problem with. That really helps me get down to your exact issue as quickly as I can. So if there's nothing else, everyone have a good evening.
Hey, Professor, I have a side question that's not related to the assignment.
Okay, go ahead.
So it's about the due dates. So I noticed that the due dates are Tuesday, but if we turn it in on Tuesday instead of two or 3 days prior, we don't get full point. It seems like we're getting penalized
Are you talking
for
about the discussion or the assignment?
the discussions.
I mean, that's actually correct. If you look back in the syllabus, along with some messages that I've posted in the course announcements,
Mm-hmm.
with the discussions, and it's not just for this class. This is how the discussions are supposed to be for all the classes. At least all the computer science classes I know follow the same format with the discussions. Your initial post for a discussion has to
Mm-hmm.
be on Saturday or before. And that the Saturday is because it's 3 days prior. If you look at the syllabus and the grading rubric for the discussions, it says for full credit, your initial post must be 3 days prior to the due date. And the reason why that is because part of the discussion is you also have to reply to other students, right? So, what if we didn't have that initial post requirement, right? What if everybody waited until 11:30 p.m. on a Tuesday night before they made their initial post? That doesn't give anyone adequate time to respond to another student to provide meaningful input to other students. That's kind of why that requirement is in there for the discussions. None of that applies to assignments. Assignments are exactly on the Tuesday night. But that is the reasoning behind the 3 days prior for the initial post of your discussion. Like I said, I know it applies to all of the computer science classes, but I think it's generally UMGC wide.
Okay, I understand. Thank you.
Okay. All right. Everyone have a good evening, and I'll have this video posted up here in the next hour or so. Thank you.